morning, good afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our expert panel or expert webinar, Getting from Data to Generative AI Quickly, brought to you by our friends at Hewlett Packard Enterprise. I'm Brian Mink, co-founder and president of Data Science Connect, the world's largest data and AI community. Today, we're excited to welcome hundreds of attendees from all over the world to learn how to fast-track your journey from raw data to actionable insights using generative AI. In this webinar, you'll hear from Tyler Britten, AI solution engineer at HPE, who will cover the key steps like data preparation, model selection, and optimization, along with practical use cases across. You'll walk away with the keys to unlocking the potential of AI-driven innovation and streamlining your path to building intelligent, automated solutions. Before we begin, a few housekeeping items. To make this feel a little more in person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and other information you want your fellow attendees. Next, please take advantage of the Q&A and chat features throughout the webinar. Be sure to upvote the questions you'd like Tyler to address. If you're wondering how HPE can help you on your AI journey, check out the poll question in the right sidebar. And finally, to learn more about the latest innovations in supercomputing for AI, check out the call to action below throughout the webinar from our sponsor, HPE. Now, without further ado, I'm going to welcome Tyler to the stage.
Hello.
Hi, Tyler. Welcome. Now,
thanks for having me. Hi, everyone. As we were, one other thing I wanted to mention, we have there's also another poll on the sidebar, just asking sort of how experienced you are with generative AI. So, anything from I've never really used it at all through, hey, I have a full-blown production application. So, yeah, with that, let's get started. So as Brian said, my name's Tyler Britten. I'm a AI solutions engineer with HP Enterprise. What we want to do is talk through, how we can get from, your data today to using it for generative AI. So, kind of what are the steps? How do we get there? What are some examples? And we'll have, I promise you, we won't slide you to death. I have a number of live demos and love to take your questions in the chat as well. So just a quick background on HPE as it relates to AI. People are fairly familiar with us from the HPC world, whether it's HP Enterprise, previously Cray, SGI, building, some of the largest supercomputers in the world. We are well known in that area. What HP saw, a few years ago was, there's this growing AI market, and the kind of the challenges there was a big gap in the middle. So at the one end, you have the OpenAIs, Meta, the tier one cloud providers that are offering AI solutions, even AI platforms, fully baked. And the other end of the spectrum was open source tooling. So a lot of excitement, a lot of use in the open source environment. But then finding something that was really like supportable, it just moves so fast. Finding something that was really supportable for the enterprise. So what HP decided to do was make a couple acquisitions, two of them being Determined AI and Pachyderm, and that's actually how I ended up at HP as part of that Pachyderm acquisition. So a couple different AI tools, and decided to let's build a platform around that's really pluggable and easy to use. So let's talk about large language models. There's other pieces of generative AI. But I think kind of what most people are most interested in is large language models. So kind of talking through how they get built and sort of the requirements that are needed to build something like that. So you can see on the left, compared to say a newborn is the model definition itself. So this is what do the layers look like, the structure of the model itself. Is this a transformer model? Which most are, and how the layers are configured. So that's the initial model definition. It's fairly small comparative to what the output is, because it hasn't been trained yet. So what we used to call training, we now really call more pre-training, which is this is where we're going to do the bulk of the work. So this is from a compute perspective. So this is where we're going to spin up lots of GPUs, and we're going to take large amounts of training data and run it through the model and start setting those weights to that model and giving that model its ability to start being able to generate text. We'll see some of the, if you look on Hugging Face and some of the places where you can look up open source models, most of the time the person releasing the model will give you the details of what they trained it on. Hey, this took 100 A100 GPUs and we trained it for 18 hours or something like that with this data set. Sometimes they don't, but usually you can get an idea of the amount of both data and resources that went into that pre-training. So once you have that done, you have a really good what we call token generator, right? So it's going to you can give it a set of text, and it's going to generate sort of like the next most likely words or tokens or what have you. So this is a lot of times where code creation models stop because they don't need instruction. So right there, you just stop and you're feeding it little pieces of your code, and it's adding to it. The next phase is instruction tuning, which is much more common for general purpose LLMs, which is then you're giving it the ability to understand you're not just completing, but you're answering, you're accepting instructions. So hey, please answer this question, please summarize this document, please convert this from one language to another, those types of things. So that's a little less resource intensive, but still something that generally happens, with the initial model training. So that's where you'll see like, oh, here's Llama 3B, Llama 3 8B instruct. You'll see them named often instruct, that they're already been instruction tuned and are ready to go. Then from there you get into those next level. Now we're beyond those basics. The university level is we're doing fine tuning. So this is where we can take a model. We don't have to train it from scratch. So if you want to take an existing base model and then fine tune it further for different reasons, and we'll talk a little bit more about that. That's where you do that. And then the final piece, once you're ready to use it, is inference. So we have the model deployed. It's plugged into some sort of application that's providing kind of your value. So this is how models generally move. And a lot of times you're not going to be doing most of the time, you're not going to be doing the stuff on the left-hand side. So you're going to start with a pre-trained model that's instruction tuned and ready to go. You might not even need to fine tune it. And that's some of the examples we'll go through. We actually don't use any fine tuning. So if we don't use any fine tuning, what do I do with a model if I'm not using, I'm not using OpenAI, I'm not using something with an API endpoint? How do I actually run a model, inside my data center walls? So this is something I get asked a lot because they'll say like, hey, we're allowed to use a generative AI, but we can't use any of the services due to restrictions, security restrictions and things like this. So you can use technology like, for example, I'm going to use for this demo, this is not the only way to do it, but we have a product called machine learning inference software, which allows you to pull models from places like Hugging Face, NVIDIA's NGC catalog. They have NIM-based models, and we can serve them out and scale them up and down. So if I just want to take a sort of an off-the-shelf Llama model and serve it out for my users to use with their applications, this is a fairly straightforward way to do it in a sort of enterprise-grade way. So let's stop there and let's with the slides, and let's pop over to a demo. All right. So this is my MLIS environment. So you have a number of registries you can configure, and you'll see here we have some OpenLLM, which are Hugging Face or NGC. So we're pulling this from NVIDIA's GPU cloud, and then from there, once we have a registry set up, we can then package up a model. So if we take a look at, let's pick an existing model. So Llama 3.1 8B instruct. This is the one we want to serve out. This is where we can configure, which registry we want to get it from. If we want, what format the model comes in, you can pick it. In this case, I'm using a custom one using VLLM, but you can pick all sorts of other ones, the types of resources it needs. So in this case, it needs 1 GPU, and any other advanced settings I need to give it to deploy it. Once I have my model configured, I have it set up to be served out here. So if we go, here it is. So we can see there's that 3.1 8B instruct. V1, we have also model version. We'd see we have a GPU, 10 gigs of memory. It's served out. And if I click here, I can get access to the endpoint, and I can see not only do I have a normal sort of endpoints, I also have OpenAI API compatible ones. So anything that can talk to OpenAI can talk to these endpoints. So I actually have Open Web UI, which is a nice tool from the Llama folks. I have it set up and configured to point at that endpoint. So this is that 3.1 8B instruct. And then I can just use it like a normal, like I would ChatGPT. And here we're getting our answers right back, just like we were using ChatGPT or something, one of the services. I can keep track of them. I can also say upload a document, ask some quick questions about that. Um, if we go back to our interface here, we'll see, here's the information about it. We can also click on the dashboard and see that model in use. So you can see it was pretty quiet. No one was using this model right now. And then I started putting in some requests. You see the requests per second start to go up. You see the successes. And I can see in the logs what was happening here. So it allows me to deploy one of those models and monitor it. And as a good starting point for a user that's used to something like ChatGPT, they can get an initial experience with this fairly straightforward. So this is just an off-the-shelf model being served off by a server in my data center, and I'm getting this on-prem, experience like one of the service providers. So really, that's fine. I asked it a question from the history book that Llama 3 is trained on a very large data sets, a lot of information from the internet. So general purpose knowledge is in most of these models. But what if I really need it? Where it gets more interesting is I want it with my data. I don't want just a general answer. How do I do that? So one of the things I have to do is I need to get the data into the model. So what I'll show you, our next demo where we're going to get into this a little bit more is we use a platform called Machine Learning Data Management. So this is, formerly open source Pachyderm. And this gives us a pipelining tool to allow us to process and suck in a whole bunch of documents at once. So we can load it up with a whole bunch of PDFs and do all the pre-processing and have it ready for us to ask questions about those documents. It also can do a lot of other things, all sorts of general pipelining, whether it's ETL type pipelines or other machine learning ones. This gives us the capabilities to process and transform data in large volumes and get it ready for AI use cases. So let's actually switch back. Let's start with the end result. So let's switch back to this other screen. A simple RAG application, which is retrieval augmented generation. We'll dive into in just a minute, kind of more about what that is and how we build that type of app. But you'll see here I've picked that same 3.1 AP model we were just looking at. These are some model settings that are common for LLM. So the model temperature, so it's how deterministic the model is. This is we're going to pull these chunks of data out that we've to answer the questions, and then we have some basic setups like LLM instructions. So for this tag here, this Telegram one, I uploaded a bunch of different articles about the CEO of Telegram being arrested. So if we just ask the question, what happened to the Telegram CEO, we're going to get an answer: was arrested. And there's our information, but we want to see what the sources are. So this is where retrieval augmented generation comes in really handy, as we can see the source data, we can see how relevant it was, and then here we can even see initial data. So this was actually, these were in multiple different languages. So I used Llama 3 to first translate this article from Portuguese to English before I used it for this use case. You can see some other ones here. So we can see this one's from Russian. So there's the original Russian, and then here's the English for it. So this was all passed to the LLM to allow us to answer those questions. We'll come back to this in a second. Let me just kind of show you how we build a RAG application. So this is what you're sort of used to, is where we ask a question, we send a query to a chat model, what's the world's fastest supercomputer, and then there's also usually a system prompt. So this is where the instruct piece comes in. So this is how you tell the model, hey, in this case, you're an assistant charged with thoughtfully answering questions. Please, keep your answers as brief as possible, but explain them. Any of the instruction you want to give to the model goes in the system prompt there. So without any sort of retrieval, it's doing regular text generation. So we combine the query, the prompt, we send it to the model, and it'll give an answer. You can say it says as of June 2021. Meaning you're based on where the data was when that model was trained. So it says using open source models, depends where the training was. We can even check, we checked that Llama one. I think it shows late 2023 was the most recent data in the data set. So what can the developers control when you do this? You can pick which model you want, Llama 2, Llama 3, Falcon, the temperature, some of those settings. We can also mess with that system prompt, which we'll go back and do. In the demo interface, we'll change some system prompts and do some things like that. And then you can also include things like we call guardrails to control what queries you're allowed to make. So you may tell it, no, we're not answering that question, or I'm not allowed to answer that question, because it may be something like you're asking a model to do a medical diagnosis, which you don't want. Last is how the responses are displayed. So do we have it as a back and forth? Is it a single question answer? These are all the things you can control. With retrieval, so what we're doing there, what we just saw in that demo is we have the concept of a vector database. So what a vector database does is it allows for the concept of similarity search. So if you're familiar with your regular search, whether it's on your computer and you hit Control F and you say like type something in, it's finding exact matches or at best fuzzy matches. What semantic search does, it allows leveraging a thing called an embedding model. It allows you to search for data by context. So it's most similar to it. So what we do is we take the data and we chunk it all up and we put it in a vector database. So when we ask the question, we can get it, the proper chunk to give us a proper reference. So you can see here, the documents are prepped as chunks of text, like those are those chunks we saw at the bottom. The embedding model converts them to embeddings. What that really means is it converts them from words to a series of numbers or vectors, and that's what goes in the vector database. So what's different is we send that we also embed that query when you ask. We go to the vector database and say, give me this many. Say in this case, it shows 3. Give me the top, 3 chunks of data, and then we send that to the model and say, using this as context, please answer this question. So then now it's limiting how it answers to the data that you passed over to it. So this obviously eliminates, the problem of older models that don't have information in it. It also gets away from, sort of the problematic issues around having to fine tune. So if I want to take a model and fine tune it with your data, it may answer better, but it's still the likelihood of it giving what we call hallucinations or incorrect incorrect outputs is pretty high. By limiting it to the context we're sending it makes it much more accurate. I see there's a question in the chat already about doing it. So we're looking at unstructured data, right? We're taking chunks of documents. We'll go a little bit more into that. And then I should be able to pull you up an example of using it with structured data as well, because that's a very common question. So there you can see here, the answer is world's fastest supercomputer, Frontier, #1 in the top 500, based on the chunks of data. So you can still, as a developer, control all that same stuff. What's my prompt? What queries do I allow? All those, what models. But now you also have what documents to use, how to prep the data. So and we'll show you when we get into sort of how we built and go back to the demo. You'll see we can control how they're chunked and prepped, which models you use to do the embeddings and retrievals, and how it's done. So you can see you can do both. Semantic similarity, keyword search also. You can do, you have a lot of knobs here. And like you talked about here is what's the how many do you want? So you can say, give me the top K. So, hey, what's the top 5? Give me the top 5 chunks. You can also do things with a show off, which is cutoff, which is you can have a similarity level, which basically it should be 70% similar or higher, and give me the top 5 of those. You obviously can use a fine-tuned chat model, but we generally see people doing that more for changing how the model sort of generates more than data. So it's like, hey, we want a model that's fine-tuned on our contract language. So when it generates this answer, we want it to answer in the way it sounds like in our contracts. You would do that more so than like, we need to fine-tune it to put the data about all of our contracts in it. Again, yeah, how the response is displayed, and that even includes those chunks. So like in that interface we could see the chunks where we asked the questions, what were used that went over to the model. So we'll dig into that in a little bit more detail of how that works. All right, so we're back here. Let me just clear this out. Also have some public documents from the Army about aviation. Talking about just general policies and procedures. You can just download off their website. And if we look, we'll use the same model. So model temperature, like we said, this is how deterministic it is. So generally for reg, we want on the lower side. top K, this is maximum number of chunks from the vector database. Maximum output tokens, that's 2000 is fine. This is our system instructions. So it has the rest of it of the please use this context to answer the question. But if we want to add additional things, we can do this here. And then the similarity cutoff, we're saying only use answers that are at least 70% similar from a semantic search perspective. So if we have something like, we're going to get the answer, and it gives us our shorter answer there. We can see our sources here. And this is where it gets really powerful is we want to know, here's my source document. I want to go directly to that document, and not only to that document, but the section of the document. So we were on page 36. So it said, hey, I got this from page 36 of this document. It's going to take us right there to see that chunk. So we can not only get our data, but we can also confirm that the answer is right. So one of the main challenges we see with generative AI in knowledge use cases, whether it's RAG or even just using a model, is the user being sure that they have the right answer. So in cases where it's more of like a help desk type use cases, it's a lot harder because the user just doesn't know what the answer is and has to take what you give it. But when it comes to more like expert assist use cases like this, where you say like, okay, I know what the answer is, but I have 100 different manuals that are hundreds of pages each. I need you to get me to the right page on the right manual. You can give me an initial answer, but then I can double check it here by clicking and seeing what the additional details say. So that's how you can do it. We can even ask things like we can even add anything you want to the. So if you said something like, we can even ask the same question again and see what happens differently. So you can see now it says it's stated in paragraph 419, pilot and command. You can also say something like answer in the form of a sonnet. So yeah, so this is where you can kind of sort of test those instructions with the model, but now we're answering questions that are very specific to this data set. So this is the different types. Again, we can show our sources. So this gives us, now we're getting reliable answers from our data that could be as unique as my data provides. So in this case, for this one, it's the World Factbook. So I can ask questions about like, sure it's in there. So the question that comes up here also about getting the RAG data in there. So let's take a look at that now. So I mentioned earlier, machine learning data management. This is how we do it. So this is what behind that app we were just playing with, this is what it looks like. So we have our documents up here. We have a step to parse them. We have a step to embed them, meaning put them in the vector database, and then we're sharing it out here. So this is where this is the user interface we were just logged into. This is the API it's connecting to get the data. So if we take a look here, what this looks like. See here we have these 3 different folders. See, this is those tags we saw in there, and then within there we have the different files. And this is keeping track of the change version. So one of the things that's nice is we can see, hey, in this commit, sort of like GitHub, this commit added, these files, and these are the ones that get processed. The other thing that's really nice is you'll see here the last job. So you can see these datums. So this keeps track of all the files that are processed. So it's skipping the ones that we had previously processed and only processing the new ones. So you can see in this case, we processed 7 new PDFs. So that's these here, right? Or, whatever, several, probably a dozen meg or so. And they're PDFs, so they have to be fully OCR'd and analyzed and all those things. So that can take a little bit of time. What you'll see here, you see this little number 2 here, this is how many workers we have for this step. So in this case, we processed those 7 of them, and it took 19 minutes to process them. They have, I think this one you can see has 89 pages. They're around like 100 pages of PDFs that it's going to just go through each one. So, that's the longest type of document to import is a PDF, especially if there's no text also saved in it, because it has to do full OCR. So that can take a little while. But we could also spin up a lot more workers if we want to process more. Look at what the output looks like. So you can see these are them added here. And these are what the chunks look like. So you can see we have our content. We have some metadata, right? What was the source? What page number? What language was it in? What tag did it have? Let me see if I can show you. All right, let's see. So there's a question in the chat about format or graph or infographic format and unstructured. So this is definitely something that's that can be a challenge and really depends on the tool you're using to process it. So we're using in this case an open source tool called Unstructured.io, which does a pretty decent job. They also have like a pay API version, but they have an open source one which will go through it and try and find things like tables or figures and extract them separately. There's a couple other tools out there. It's to each one. It sort of really depends on your data set. If you're just sort of, this one is pretty good for general purpose. I put a lot of stuff in there, but generally we recommend tuning it for, configuring it for your specific use case. The other things is the settings. So how do you want to chunk it? So this is like, I have these chunks. I don't want to just pick random chunks of that document. I want to keep things that go together. I don't want to break a table in half. So that's some of the different ways you can do it, is different chunking strategies. So you can say, hey, definitely don't break up a table, and then keep them, keep these chunks together based on like that document had a lot of like title. You can see here, it links us to here. So this, you'll see it has a very structured settings here. So so this is where you, by title, we probably want to like, this should be a whole chunk, right? This should be a whole chunk. There's limits. You don't want them too big from a number of tokens perspective. You don't want a really, really big context window. So you want to keep it to the appropriate thing. So there's different ways to chunk those up. But that's something, again, you would tweak and change as you go. Another question: context, tabular data, unstructured. We ask the question so you don't lose the context. Yes. So one of the things that we generally do is, most of the large language models are heavily trained on HTML. So they understand the concept. So a table in I think they'll usually do okay with Markdown, but I feel like HTML is the most safest way that we do it. Whereas we'll take, like, say, for example, we had a table as part of our source, that it will supply the table in context in HTML format. So that way it's easier for the model to understand it, because they can understand tables. I've seen that with use cases with, for example, like looking up, hey, I have a table of a bunch of like contract end dates. Hey, give me all the contracts named from the dates they expire, kind of thing. And it can understand the concept of tables and stuff like that. And once we have that, then that's when we go to this embed step, where we take in all of those JSON files, all those chunks, and then we run them through our embedding model. So what we're using is this is a open source model from BAAI. It's BG large. So we have that shared out, and this is what we're using to do both the lookups. So if we take a look at we're using this to both do the lookups as well as the embedding. So these are all from me asking questions. It's embedding my query with this model and reply with the right vectors to send to the vector database. One is that same front-end interface we're using, but we're using a SQL-based retrieval backend. You can see here, this is the source. This is what we fed to the model. And then it says here, the top cells. And if you scroll down, additional data here I have here is, this is the SQL query it ran. So instead of saying, go get this chunk out of the database, what I'm actually doing is saying, convert this question to a SQL query, run the SQL query, take the response, and give that to the model. So this is a way where you can do that same retrieval augmented generation, but retrieve from a structured database. Like this, for example, this backend is the Chinook sample database for SQLite. If you're not familiar with it, it's a pretty common demo database. But this is a structured database with like album sales, and so this is where this backend in this case is this simple SQLite one. I may not like that one. So here we go. So return these invoices, and it shows us what the SQL query was. So this is that. It could be pretty much any queryable backend, and the way you use it. So in this case, I'm using a tool called Vanna AI. So what Vanna does is, you can see some of the questions I've asked. What it does is it creates training data. So we start with the structure of the database. So we tell it, here's the structure of the database, here's the different tables. And then these are some sample questions. You try out questions, you can save them, and it learns while you ask those questions how to retrieve better. You can even do things like called documentation, which could say something, add a piece of training data like that, which is basically what we call documentation. So that way, if my users are normally used to saying, now it knows, based on the training context we gave it, is that sometimes if I say records, what I mean is albums. So that gives you the ability to then make it even more user friendly. So this is how you're not actually, the base model we're using here is the exact same Llama 3 model. The only thing we're using is what Vanna AI gives you is like a little database of the queries and things like that we could feed to the model to help it generate the SQL queries. So what we do is we take this, we use this, we pass that information to the model to generate this query, we run the query with the output. Then this is yeah. So this could be something in something like a large data lake like Snowflake, or it could be in your SQL database or one of your BI databases. Where we've seen the growth of structured data RAG is sort of like in a lot of BI use cases where you used to have to like open a ticket with a BI group to get like a question answer, a new dashboard that they know how to like structure the query. This is building the query for you. The question is, how do we keep this up? So yeah, so this is things. These are very sort of getting started POC. We're getting value out of this, but like we need to like take a look at the code. The actual model itself, the data science pieces, the model is pretty non-changing. The main thing we're doing is the stuff around it. So like tools like Vanna, things like Llama Index or LangChain or other, your actual code around the model that's using the model is where you're doing a lot of your development. So it's you're following your traditional application development practices. So things like CI/CD tools, testing, all of those things from a sort of structure perspective. And then you're also doing regular evaluation. So evaluation is a common step too, which is, hey, as we add data, how are the answers? Are they getting worse? Do we have a set of test data? Really common thing is have a set of test data with a test framework that you run through your app, and it gives you the answer that it already has the answers to make sure that they're answering properly. One truth of, are you making your app better or worse as you add more data, things like that. That's also where you also have like what we call like red team type tests too, which is you have some tests that would like try and get the model to answer something that it shouldn't, leak potential data, and you run those through as well. So that way, it's just like traditional CI/CD. It's just sort of using LLMs at the center. So the questions came in: do you manually set all the SQL example queries, or is it adaptable? It's adaptable. So what you'll see is you'll save them less and less. So the first thing you generally do is, you can see these say null, but they're actually, oh yeah, here they're DDL queries. So to build the structure of the database. So this has a baseline. So you can do this. There's, depending on the database type, there's different sort of initializations you can do for this to tell it like, here's the tables that exist, here's their relationships, because that's like a big piece of it. And also, obviously, the more clearly named your columns are and things like that, you don't need more training. But what we find is at the beginning, you'll ask questions, you'll tweet, you can even, so like if you ask a new question and it gets it wrong, so like this is where we can, if it was wrong, we could say no. This is where we can edit it, and then we can say save this as an example. So it goes, okay. So generally what we see is like one or two examples of roughly similar queries in that, like, oh, I'm joining these tables trying to get this one answer. Once you get that, as you make changes and ask for different timeframes or other things, it picks it up pretty quickly. So at the beginning, you end up adding more stuff to the trained data set, but it starts to tail off over time. Good question. Gen AI-based models to replace traditional models get similar results. So yes and no. So the idea being is, if I have a model that say does data classification or something like that, or say risk prediction, in some cases LLMs can step in those places, but what we've seen is it's not effective from a standpoint of cost and accuracy. So a smaller traditional, say for example, risk model that you're scoring, say, credit card transactions with, will be much more effective, both from a output perspective and then also from a cost perspective, because it doesn't need as much overhead. I think we'll see more as we see some of these newer reasoning models and some other footprint. I think there's definitely a want of like a traditional ML model for something like, hey, check my logs and look for anomalies. But they don't want to like set up a whole data set to train the whole thing. So they're like, could we sort of interactively train an LLM to understand these things? And I think there's some interesting things happening there, but it's just not really there yet. Both from a cost perspective as well as from a capability perspective. I want to jump over to another RAG demo here, and then we'll show you how this one's built as we get closer to that sort of production use case. Using this is a former coworker of mine built this. He's a big fan of Mercedes-Benz. This wasn't built for them or anything like this. This is just was a hot, sort of a fun thing for him. It's an interactive chat based on your model. So if we say, let's pick a 2023. I don't know a ton about Mercedes, so let's pick an SUV. Okay, so then I can ask it something like, give us the answer. switch on the vehicle, gives us the whole thing, and then gives us a link to the owner's manual, just like we were looking at with our other demo. But let's take a look at this is what that pipeline looks like. So this has a lot more steps. So we're taking the actual owner's manual, converting them to text from the PDFs. We're chunking them up. We're creating those embeddings. In this case, we're serving out the chat models and everything too. We're running the vector database. But the idea is all we have to do to add another model is put it in here, because we have it set to automatically extract the model names, the model years, the types, the shapes using the model. So that way you don't have to like manually have a table of all the different models. When you add a new one, it's going to automatically be able to populate in that list as well. So these are the types of, more advanced when you can run this as like a full, like this is what the end user would see kind of thing versus some more of a starter app. So you can see this one, from that other diagram is a little bit more complex, and also want to show you this so you can see like the components we're using. So, people kind of see it as like this fuzzy thing, like, okay, like a llama model. All right, I downloaded it. It's a bunch of files. Like, what do I do now? So, you can see a lot of this is in Python. I think I saw today GitHub Enterprise is happening right now, the GitHub conference, and they just announced Python just passed Java as the most popular programming language on GitHub currently. So that's not surprising with all of the explosion of it in AI and ML. So we're using, this is mostly all written in Python to, convert those, pull out the metadata, chunk up the text files, do the embeddings. In this example, we're using Weaviate, which is another vector database. The other one I was using ChromaDB to do those vector searches and filtering. So in that case, we can filter based on year, model, and body type before we pass it the question. So that way it doesn't have to, look at chunks from models that it knows aren't. And then you'll see we're serving out the chat model, embedding models there. So in this one, we're using Salesforce has their embedding Mistral. It's a Mistral-based embedding model. And in this case, we're still using Llama 2 7B. But we can do, we can use other models in that case. And then Streamlit, Gradio and Streamlit are two most common like rapid prototyping front end pieces where you can make it really easy to build a front end using, again, just some Python and get a pretty usable UI fairly quickly to begin, sort of going through the testing and seeing how users, like the AI piece of the application. You have to, build an entire, super advanced question about vector database index creation. Yes, so this is a bit more of like a deeper topic for a longer time, but depending on which vector database you're using, like a common one I use is PG Vector. And the reason being there is a lot of people, a lot of customers have pretty decent amount of Postgres knowledge in-house. They may run some other Postgres databases. They have some DBAs that are very familiar with Postgres. So you're already bringing AI, you're bringing in some embedding models, you're bringing some different stuff in. Why also bring a brand new database as well? So PG Vector can scale pretty large and is pretty effective. So I frequently use that. But all of these databases, there's Milvus, there's Weaviate, there's a whole bunch of them, OpenSearch. And what happens is at a basic level with PG Vector, you're just enabling extension that allows the ability to add a column type of vector and then allows you to search against those vectors. And the question in the from an index creation perspective is like, well, it's fine if I have a little one, but I have a pretty big database. I'm doing a vector search. So the vectors itself are, a string of float numbers. So, doing these nearest neighbor searches can get expensive. So that's where you create indexes, and there's different types of indexes based on the database vendor and structure. The most popular one for PG Vector right now is SW, Hierarchical Navigable Small World. So the idea is it sort of breaks this whole giant vectors. Because if you imagine every one of your chunks is basically drawing a line, it's a vector drawing a line on a graph, and you're like, I want to find the section of the graph, what's the closest. So instead of plotting every other single line, every other single vector in the database, like get me close enough so it breaks it into smaller sort of navigable chunks. So that way your searches come back faster. So like I was working with someone, they have several million rows in their vector database, and they still get results back fairly quickly because they're using indexing. It's very database, how it's implemented, how you configure it. So whether you're using Pinecone, pgvector, or something else, they're all very database specific. But there's definitely indexing capabilities. It's usually you're paying a lot more of a penalty on ingest to do the indexing, and then it makes you really fast for retrieval. Another question in here, logic component, text parse and lookup. This is exactly what we were talking about when the metadata is using the filters in the vector search. We parsed all of the text from the PDFs. It assembled the list, which we can actually, so if we look here and take a look at what the output is, we've just converted the manuals to text. So you can see this is a 2020 A-Class sedan. See the metadata, so it's extracted for the file name, what the model is, what the year, and the type. And then what that's added to each of the chunks as metadata. And then when you query it, because we picked up front, we picked the model, it filters on only the chunks that are marked with those metadata. The same thing is what we did over here. So these sources are a tag. So I'm saying like, hey, only use the World Factbook with this tag. That's what that tells. So we're doing filtering. So you can do that. This is the most simple way, is have the user pick. Another way is you could feed that information to it. So like, for example, if you had a bunch of different users, they were answering questions about their laptops, and from your ticketing system that they have a Mac and this model Mac, you may pass that to your RAG system before their question is passed to say like, hey, they're going to ask a question. It's about a 2020 MacBook, M1 with this, instead of having them pick it because they may not know. So you could, so you can do that. Then it's where you start building things into our advanced capabilities. So this is what we consider like traditional or basic RAG, which is get chunks, return them, answer a question. Where this is really starting to grow is into what we call agentic, or using agents. So the idea is you use an LLM as an agent where you tell it what to do. You say like, hey, I want to do these types of things. You have these tools available to you or these other agents, and it makes decisions of which ones to run. So to say like, hey, if you said like, I want to know what's different in the trunk dimensions between the 2020 model and 2024 model, you would have an agent that would say like, okay, I need a research agent to go get those dimensions from each of those. Then I need a comparator agent to compare them, and then I'll return the answers. So you can do some capabilities like that to be able to this is where that's like the next phase after it. So like LangChain is really popular in that space, but that's where you build like really effective, really capable, beyond what just an LLM can answer. And as the agents get smarter, with the capabilities you're coding, the lift of the LLM itself gets smaller. So like for example, people say like, oh, I want a big enough server so I can run, Llama 3.1 400B. Like, well, you probably don't need it. Like a lot of our users were seeing a lot of them are running the 8B. They're not even running the 70B version of Llama for a lot of their use cases because it's good enough. They don't need to chew up multiple GPUs for it, and they get they get the capabilities that they want to want to be able to want to use. Let me switch. We're coming up towards the end of time. I just want to show you a couple other things quick, and then answer any of the remaining questions you have. So one question that I usually get is, "This is cool. Hey, we're on that. Like in the kind of poll space. Hey, we're on more the like, hey, we played around a little bit, or I've used the service, but we're not really doing anything in house." Started. So one of the ways we have a thing called a Generative AI starter kit, which is we package up a server, operating system, containers, some of those tools we use, and even the templates. So that RAG interface I was showing you, that comes along with it. So you can throw some documents in it and get started fully on-prem today. So it's one way you can get there. It also includes 40 hours worth of services to help you understand how to integrate it with your, and get your first use case done. So that's one way we can, if you're looking for how do I do this on-prem, a number of customers that have started with this, have some started, some basic document question answering, and really scaled from there. I would say it mentions in here one thing we didn't have time for a demo for. Code generation is very popular as well. So hey, we'd love to use GitHub Copilot. We don't allow it here. We want to, but our developers would love to have some sort of code completion capability. So, we help users stand up something like one of the open source models like StarCoder, and then they can plug their IDE into it. Like I use VS Code, and I get code completion, and it's all inside my firewall. So that's another thing you can get stood up pretty quickly with this setup. That's all I have from a content perspective. Let's see what other questions we have coming up here. Okay, yes. So a question came up, and Dimitri clarified predictive logic component to these. So at the very basic level, the difference is there's a couple differences between just Control F, right? One of the things is we're depending on the model you're using an embedding model to find semantic similarity. So these words put together in these way are most similar. So I can ask a question and the answer does not have that word, any of the words from the question in it, right? So there's some amount of, and that's one of the things you can do as well as part of, kind of developing these things is one of the first steps in those like pipelines to do RAG is turn the question into an answer first and then use that for semantic search. So that's one way you can even improve your results. So what you're trying to do is you're saying what chunks of text are in structure and content semantically most similar to the question I'm asking, which, like I said, doesn't necessarily include your actual keyword. So this is where it's more advanced in keyword, but you can also then use the LLM to do some of those things like, hey, common ones, rephrase the question. So one of the things I think we know from even search days, people struggle with asking, they'll say, I Googled this and I couldn't find it. And then it's like, well, what'd you ask? And you're like, well, why'd you ask it that way? So one of the things you can have the LLM is to rephrase the question. So that's where you can get some additional logic to make it smarter and make it retrieve better. And those knobs, like we talked about from a developer, that you can tune to make the thing better and better. Out of the gate, semantic search is dramatically more effective. It's even more so if you have, depending on your data structure, if you have like a graph database, it's significantly more effective. But you can build these things as you go and improve upon them with those things. Policies. Yes. So the question was the RAG use case, policies and procedures for knowledge search, and the persona is the person who doesn't have the answer is accurate or not. So I'll be real straightforward with you here. I've seen a number of large companies trying to build a RAG application to answer like customer service type use cases. And for those cases, they need to be 100% accurate. They can't tell you the wrong thing. Like if HPE internally was building an HR chatbot, and I asked it, do I have every Friday off this month? And it says yes, that's the wrong answer. So what we do is they start building up a knowledge base of questions, golden questions and answers, and scoring it. So usually you can get into the 80s pretty quickly, 80% accurate, and you start slowing down there. And what they'll do is as they start getting more, as they start still finding wrong answers, they keep adding more questions to the test set while they tweak it. And what they end up having is a really effective frequently asked questions generator. So this is kind of something I'd want to end on here is really where's the most value in the lift. So for example, I have another customer who uses these tools to generate knowledge base articles from trouble tickets in IT. So the thing is it can't generate 100% accurate knowledge base article based on just the contents of the ticket, but it takes a lot of the heavy lift because they generally don't have their help desk doesn't create enough knowledge base articles because they close one ticket, they want to get to the next one. They don't have time to type up a whole summary. So that's where the LLM steps in. It reads the ticket details, it gets them a good summary, and then it just passes it to the help desk operator to just tweak it, double check it, tweak it, and save it. So that's where we're seeing that same thing there. So instead of just saying like, hey, this could answer any question you could possibly ask, it's like, hey, we're going to have a really robust database of questions that we know have known good answers, and then it's going to decide which question you're asking and feed you the answer. So that's something to get those like 100% use cases. The main thing driving the accuracy of it is still around prompt tweaking. There's just so many little knobs you turn to get it better and better. But the key thing is having a a measurability to measure against. So you can't just guess, does that feel better? You have to have, hey, we have a test we run and see how it's scored. One last question we'll end with now, since we're at time, is how do I get started? Um, you can get started with, if you've never touched any of these things, you can get started with there's a number of those I mentioned at the top, number of the services that have offerings. If you're looking to get hands-on, say in your data center, HP can help you with that. Like I said, hardware, software, everything in between. The large cloud vendors as well. Like those are the places where people really get started to start building their own applications. And do a lot of reading. There's a lot of great blog posts I've come across over time about building RAG systems, and people are, one of the great things about AI is people are really willing to share their knowledge while they work, and I've learned a lot that way, and it's one of, I think, the big things that's really nice about the so with that, we are out of time. Thanks everyone for joining. I really appreciate the questions, really good questions in the chat. It was super interactive. Thanks so much, everyone.